A single railway track means that only one train can run and in one direction at a time. Having 2 tracks means a train can run on each, in either direction if required. Having 4 tracks means that fast trains can run on 2 lines, while slower trains can run on the other 2. But what do we need to consider when designing tracks next to each other? Stopping the trains hitting or glancing each other as they pass. This is prevented in 2 main ways, by managing the track intervals and the passing clearance. So what do we mean by track interval? Simply put, this is the distance between tracks that are adjacent to each other. The distance is measured from the inside or gauge face of the rail. This is due to the fact that the flange of the wheel limits the wheel movement further across than this. Therefore, this is the limit of where the wheel and therefore the train could be. Where there are 2 lines, in the UK, the standard interval is 1,970 millimetres. This is based on a track gauge or distance between the rails of 1,435 millimetres and a requirement to obtain at least 100 millimetres passing clearance. More on this in a minute. Where there are more than 2 running lines, an additional distance has to be added. For new construction, the additional distance is 1.2 metres, giving a distance of 3,165 millimetres. When reconstructing track, the additional distance is reduced to 900 millimetres, so 2,856 millimetres between pairs of lines. You may also see these areas between the lines called the 6 and the 10 foot. The rules on track intervals are different in sidings, where a wider distance still is required. This is to factor in the likely presence of people, such as shunters moving between the trains. So that's track interval. Now let's look at passing clearance. As the name kind of gives away, passing clearance is the clearance between 2 trains as they pass each other. It is undertaken as part of gauging analysis. We have a great video on gauging, which I recommend checking out as it's a very important part of track engineering. The link is in the top right now and also in the description below. Outlines of trains, known as kinematic envelopes or swept volumes, are used to represent that full range of motion a certain type of train could achieve. This range of motion is determined by the train's size, but also its suspension, with stiff suspension allowing the body of the train to move less. It's important that the profiles show the extreme limits of the train's movements, so worst case scenarios are considered. On screen you can see now a single profile. Profiles of each train type that run on a section of the track have to be compared to each other, a job a computer can do in a short amount of time. On screen, you can see the swept volumes for multiple trains overlaid as part of a gauging analysis to a sign on the right-hand side. Something similar would be undertaken for trains side by side to each other. As we previously said, the standard requires a minimum clearance of 100 millimetres between any 2 trains travelling on adjacent lines. Inevitably, this will be between 2 freight trains, as they tend to be the largest, but also the most block-shaped. Apart from the train itself, there are 2 other important factors that affect the passing clearance: the radius of any curves and the cant applied to the track. These are somewhat linked, given that the radius of any curve in the track determines, to an extent, the amount of cant applied to the track. Given that train cars and wagons are rigid, a curve in the track creates what is known as end and centre throw. Both centre and end throw have the potential to decrease the distance to trains on adjacent lines. This is more pronounced on tight radius curves. For more on this, check out our video on this subject. The cant on the track tilts the train, which then alters how the body will sit. It causes more movement at the top of the train body, with those train types with softer suspension systems, such as passenger trains, being the most affected. You can see on this output that both the radius and the cant are factored in. Given the 100mm clearance has to be maintained, it can drive a requirement to widen the track interval. This is especially the case if the adjacent tracks have different levels of cant. So now you know about both track interval and passing clearance, and how they both stop trains hitting each other as they pass on adjacent roads. Thank you for watching this video. I really hope you found it useful. Please do drop a comment below with any questions or queries. Hit that thumbs up button and subscribe to ensure you don't miss a video. Thank you.